Hey guys, so this is the last lesson. This is lesson 9 in our packets, ionic versus molecular solutes. First, I'm giving you a little warm-up because I didn't give you an exit in the last lesson. Answer these questions to start. What is a colligative property, and what is the boiling point elevation and the freezing point depression? So let's begin with lesson 9. And you will determine the difference between ionic and molecular solutes and the effect of the number of ions produced on the colligative properties. So going to the last page of your notes, page 16. Question, why do we salt the roads in the winter rather than sugar them? Okay, well, great answers here. All right, well, sugar is molecular, and it's going to completely dissolve, and it's not going to break up into ions and yada yada. So let's talk about this in further detail. So sucrose is molecular. It's C12H22O11. These are all nonmetals, so it's covalent. The reaction that's produced when when sucrose is dissolved in water, you end up getting C12. Okay, let me get my pen here. Sorry about that. C12 H22O11 as a solid, and then we put water in there, okay, and we end up getting C12 H22O11 aqueous, okay, is aqueous solution, nothing else. Now ionic, salt, NaCl, right, positive ion and a negative ion, a metal and a nonmetal, we're going to get this NaCl solid, and then in water reacts with water and breaks up into Na plus aqueous, okay, in the aqueous solution, and the chlorine ion in the aqueous solution as well. So notice we have one product here and we have two products here. So it's 1 mole of reactants equals 1 mole of products. In the ionic form, we have 1 mole of reactants, okay, one thing here, and then we have 2 products. So the general rule is that the solute that dissolves to form a greater number of products, or ions, will have a greater freezing point depression. That means the freezing point will decrease by more, and a greater boiling point elevation, which tells us that boiling point will increase by more. So here is an example, and then we're going to figure out how many ions are produced. Calcium chloride in the presence of water to make an aqueous solution breaks up into calcium plus 2 aqueous, and remember we have to balance it, 2 chlorine ions aqueous, all right, because we could just say chlorine, but there are 2 of them, so we need to balance that with the coefficient, going back to balancing equations. So if we look, we have 1 mole of reactant and this produces 1, 2, 3 moles of ions. Or you could say 3 ions are produced. So therefore, CaCl2, calcium chloride, is even better than sodium chloride. Why? Because we have more moles of ions. Here we only have 2, right? 2. The more ions you produce, the greater of a freezing point depression you will get, okay, which means that this will work better because it's going to lower the freezing point even more and will be more effective at lower temperatures. So why don't we use the calcium chloride versus the sodium chloride? Well, because I'm giving you hints here, it costs more money. It's very expensive, but there are townships that do use it. Calcium chloride in the liquid form is called brine, or liquid brine, and it is very costly. But the winter that we had this year, guys, probably wouldn't want to use that. Anyway, okay, so you should start studying. You are going to have a vocabulary quiz before your unit test, okay? And I would like you guys to start reviewing all your notes in the packet, and any questions that you have, please address them in class during practice time. Thank you.